Okay, so an interesting look there at digital twin, Michael. So now we're going to take a trip to visit our last live showroom of the show. We're going to visit Brad Ward over at Omron, and he's going to be talking about obviously some of the machines and equipment that gather all the information to make that happen. And there he is. Hello, Brad. How are you today?
Hey, Trevor. I'm good. How are you?
I'm very good.
How are you
Very
doing?
good. So
Hear me okay?
we're doing great. Yes, it's been
Excellent.
it's been a busy 3 weeks. So we're going to have a walk through your training center, which is behind you. It looks very impressive.
Well, thank you.
So where do we start? Are we going to look at your current generation AOI? Is that where we're going to start?
Yeah, we'll take a walk through our automation center here. So I guess first is welcome to Omron Automation America. This is our Chicago office here, so the U.S. headquarters. From this building, from this room, we actually support a variety of different activities, and actually sort of right here off the bat are our mobile robots. So leading right into Juki's interesting video that we just watched. We didn't get to see the robots in that, but if you wanted to see them, here they are right here. These are the same mobile robots that Juki
carry a lot of work.
Yeah, so these are actually the same mobile robots that Juki uses for their smart material handling solution. So we're really excited about that partnership. We're doing some interesting things down in Mexico for a customer right now as we speak. Otherwise, we have a lot of other things going on in here. If you believe it or not, we actually have a live in-person AOI programming training going on right now. So that's also very exciting to see that picking back up. Otherwise, from here, we do a lot of proof of concept testing. We do a lot of demonstrations of Omron's automation products. You could see a pretty big mix of different solutions, whether they be our motion control, vision safety, sensors, mobile robots, collaborative robots, fixed robots, things of nature. We do actually have another set of labs on the other side of the building for our vision, automation, and AOI systems as well too. We thought this was a good opportunity to maybe put a fresh coat of paint on the walls with the low traffic. So we were excited to get those machines back here again pretty soon. Otherwise today, yeah, as we move into the AOI training, the AOI demo center here, I do have systems that are currently being used for the training. So I do have a current generation 3D AOI right here. Actually, for Apex, we just uploaded some very interesting new 30-minute product demonstration videos of our solutions, including the VTS series, current gen AOI, our newer 3D SPI, our 3D CT AXI systems, as well as a collaborative video that we put together with CTI to show some of Omron's automation products and smart material handling solutions and some of the custom things that we can do as well there. So I would encourage anybody to check those out. I'll be sure to upload them to our website and YouTube as soon as the show is over so that the registered attendees get the first look. But they're interesting. They definitely do a pretty good job demonstrating pretty thoroughly the capabilities and the features and functions of the system, including some actual on-site demonstrations to customers to learn more about how they're using them and the success that they're having with those and how it's improving their quality.
Okay.
But,
So
yes,
what are the features then of your VT S730? I mean, is it a combined 2D, 3D, or is it a 3D only machine?
It is very much a combined 2D, 3D. We feel very strongly that even the most modern AOI systems to date really need a powerful 2D system behind the scenes, sort of incorporated into various features and functions, but really sort of you need that capability there when it's appropriate to use or more applicable, depending on the application. And we have over 30 years of experience with that. We're not going to throw away this very proven technology that does a great job of catching defects. So 2D is certainly a piece of this, but it's a 3D world. It's a 3D system. So it's a fully functioning, full 3D platform. Everything by default uses 3D. So whether we're doing, component extraction, measuring heights, lifted leads, incorporating it into a solder joint inspection. So it is very much what we call a hybrid 3D system. Omron focuses very heavily. Our priority is solder joint inspection. That's really what tends to separate systems from one another. So our focus is very much on that as we sort of maintain our position in the market as the #1 supplier to like the mission critical and quality focused customers. And you can imagine solder joint is, their #1 area of interest. So we put a lot of thought into how we address the solder joint measurement system. So our patented hybrid approach is really the right combination of technologies to achieve the most stable and reliable solder joint inspection process.
So how does that work then? I mean, what are you using for your metrology system?
Okay, good question. It is unique to Omron, so that is a very fair question. The way we do that, a little bit proprietary, but at a high level, what we do is use sort of our experience with color image processing to first go through and basically map that entire solder joint using our patented 3D color highlight system, the red, green, blue color information that everyone's kind of accustomed to within an Omron system. So we use that to develop a first approach profile. So we get our rough shape, we get our characteristics, we get a good understanding of that solder joint. And from there, the way the hybrid system works is then to incorporate real 3D imaging on top of all that. So basically, we get our 2.5D color highlight image, then we come in with full 3D to better, more accurately profile that solder joint to get a more realistic shape and basically the best possible representation of the profile of that solder joint. So the 3D system is kind of what you expect with the the pattern moire lighting approach. It's the same thing that we use in our SPI systems. We use it in our AOI, for every single part as well.
Mm-hmm. Okay. Michael, are you familiar with these systems? Do you do much with inspection people?
Yeah, it's a huge resource of information for understanding exactly how manufacturing has been performing, because you just think about the sheer number of thousand or even million of these joints are being checked every day, and any one of them would result in potentially a very, very serious defect. And it's really looking then at the variations in the manufacturing process that create that. But with this kind of inspection, you're looking and discovering that variation before it's going to have any serious consequence. So, it is so important. And it's not just the simple case of getting a single picture and thinking that's wrong. It would be nice if the world was like that, but it's not. You have to actually compare the results from a huge range of different kinds of joints over a period of time to really start to understand the real technology that's going on within that, to be able to accurately predict whether or not that is actually a problem or not. And so this kind of technology is so impressive to be able to get that information at your fingertips. So the operator just sits there, the software will tell him, and he's got the opportunity to improve the quality. It's as simple as that.
Yeah,
and not only that, but
yeah. Back in the early days, there was a lot of false calls and things like that, and it was a case of trying to find a system with the lowest false call rate. And but it's really come on in leaps and bounds. So anyway, back to you, Brad. What have we got here?
So along with our current generation of AOI systems, we're really excited to be able to this year introduce basically our next generation of AOI system into the market. So the VTS 1080 is our new system. Really, it's right on the cusp of being released. We expect to get our first systems here in April, May, so as we introduce that to the market. So we're very excited about that, because this basically, not to exaggerate, but kind of perfects the hardware requirements in a modern 3D AOI system. So it incorporates a brand new inspection head, brand new 3D projectors using MPS technology. And if you're not familiar with that, it's basically multi-phase shifting technology, which is a better way of interpreting that 3D data that we're collecting and making it more stable across the widest variety of components. Specifically, a lot of the time, it's the reflective components that 3D systems really struggle with. So MPS digital projectors have a significant improvement in that. Not only that, but basically we're using Omron's absolute latest generation of multi-directional, multicolor illumination. So we're still using our green blue color highlight system, but in a whole new level of more colors, more angles, with the idea that this is what you need for that color image processing to get the absolute best interpretation of that solder profile, because that is absolutely critical. A lot of systems just kind of focus on, let's extract whatever data we can to make it look pretty, whereas we are very, very concerned at the true profile of that solder joint. Not only that, but doing it in a way that detects defects, doing it in a way that has low false calls and no risk of escapes, but also in a way that directly correlates to the IPC standards that we should all be following. I mean, if your AOI system isn't inspecting to IPC standards in this day and age, you have sort of a limitation.
Yeah, yeah. So what sort of resolution does your new S1080 go down to, and what sort of field of view does it have?
Well, the beauty about the S1080 is that it's ready for the future. So as equipped today, the first machine coming off the line is going to be equipped with the 12.5 micron resolution. But the hardware in there is completely ready to be upgraded for the future. So for us, we really feel like this is a standardized platform that's going to be around for a long time, because it is ready for next gen processors and next gen GPUs, next gen cameras, and resolution changes, so that we can basically use this system more flexibly through the future for a longer time. In fact, it shares a lot of components with our Xray system as well too, which is, you can imagine the benefits of that from a support and spare part availability perspective. But
yeah, is it using linear motors then on the XY gantries to give you added accuracy and speed?
For AOI systems, for us, there's such a sophisticated extraction process behind the scenes on the software side that we can use ball screw motion still even today. I mean, Omron is an automation expert. It's what we do. I mean, AOI systems are a part of what we do. We're not an AOI company. We're an automation company that sort of brings all that technology and advancements and innovations into our AOI systems. So, when we say we're motion control experts, we mean that. And that's, really true and really apparent in our 3D CT X-ray systems that has a very sophisticated motion in order to collect that sort of fast, robust CT data. So it does use ball screw motion for movement, but we're still able to achieve extremely accurate extraction behind the scenes, because we just need to get it into the right place as accurately as we can. And then the software sort of takes over from that. If you need true ultra high precision accuracy for like point-to-point measurements or dimensional measurements, we have a different solution for that called our M121, which is focused on more of the post-assembly processes and things like that. LED manufacturers as well too. The placement of those LEDs is critical, so we have an ultra precise AOI system to handle that.
Okay. Now the other area that Omron's heavily involved in is, of course, your SPI, but then also your X-ray. Do you want to very quickly go through the SPI first, or do you want to go to the X-ray?
I'll just cover the SPI real quick. We do have a new generation of 3D SPI. We actually introduced it into the market at Apex last year, so it's about a year into its cycle here. It's actually our fastest selling 3D SPI to date. It has some new cool features and functions and improvements over the previous generation. Really, the one that I'd like to highlight is that it has an industry first 3-stage resolution system, so that it has the ability to adjust its resolution on the fly. So in most products, the fixed optical resolution, and then zoom in to inspect more critical or finer pitch components at a higher resolution as needed on the fly, so that you're not sort of stuck with the potential downfall of having an ultra high resolution SPI system that's really slow for products that you don't really need it, right? You choose the right mix and balance to maintain capability and cycle time. So we're really pleased about that. But from our X-ray systems, yes, Omron is very quickly becoming a leader in the field of AXI, specifically our CT AXI system. Really, this is the only system that we produce. Omron doesn't make 2D X-ray systems or manual X-ray systems. We really make these industry flagship 3D CT ultra capability X-ray systems, because what we are we feel very confident that the future of our industry is going to require CT X-ray. I mean, AOI we talked about, you know, we're reaching sort of the hardware limits of what 3D AOI can do, right? Any future development now on the AOI side, now that the hardware has been, you know, what we feel is perfected, it's really going to be software and AI-based smart factory solutions, but the hardware is pretty solid. And there's only so far you can go with 3D AOI before you need X-ray, especially moving forward, to look at those most critical components, look at all the growing number of hidden solder joints. And CT is really going to come into play as things get smaller, as things get denser, as things get more complex, because our drive is to provide our customers with design constraint-free inspection solutions, so they can use the combination of our 3D AOI with our 3D CT AXI to ensure that they can inspect every single component on those boards in the best possible quality possible without having to make sort of compromises.
Right. Well, there's no doubt
So
about
we
it.
feel,
Increasing number of bottom terminated components on the market,
yeah.
and in BGs and things like that. And of course, you have the problem of miniaturization as well. But one of the issues has always been with the inline X-rays is being able to get the resolution, because you have to keep up with line speed, and it's very difficult to have enough time to be able to gather the resolution you need to inspect these devices. How do you deal with that?
Yeah, and that's certainly true in the world of CT as well, because unfortunately CT is sort of the pretty widely agreed, you know, undisputed, CT is the best way to X-ray components, but historically there's always been a huge challenge of time, right? Not too long ago, you know, you could add CT capabilities to a lot of systems and you could do a BGA in full CT in 8 minutes. So like, you know, that's obviously unacceptable. So when Omron introduced our first CT systems back in 2010, you know, we made it possible to inspect that BGA in just a few seconds instead of a few minutes. And as we continue to introduce new generations and software improvements, hardware improvements, make this machine faster, you know, now we're to the point where we can inspect that BGA in literally just 3 seconds. So maintaining cycle time is key. And that's really our drive moving forward, because we recognize that even today, you know, one limitation keeping these machines off the line is still that cycle time. Even though it takes just a couple seconds to inspect a BGA in full CT, sometimes that's just still too much, and we know we can do better. So that's what you can expect from Omron moving forward, is of course further improving that so that you can use the CT capabilities that you're going to need actually inline. Although this machine is not dedicated inline, so we have many customers using it nearline, offline, in an inspection cell by itself. We do have them in high-speed production lines. We have them in analysis labs. So it is very flexible for that.
Okay. Well, you know, the key thing is that making all this work, of course, is the software. And the Omron software system is a QUP Navi. This is the software that brings all these inspection images together, makes them work. And I'm going to turn this over to Michael, because Michael, this is getting more into your area. You can ask some questions to Brad and, about the QUP Navi system.
Yeah, it sounds very interesting. Is that a view from the actual software there?
This is just an introduction to the system itself. So the
Okay.
our QUP software comes in 2 flavors, QUP Navi and QUP Auto, and it really depends on how wide are we looking, right? QUP Navi, Omron sort of took an unprecedented step in the industry, and we provide every AOI customer with this QUP Navi analysis package so that everybody has access to their data. You shouldn't have to pay for that. So QUP Navi basically controls our world. Because we're a full solutions provider, we have 3D SPI, 3D AOI for pre and post reflow. We have 3D CT AXI. So that's our data. So of course, it's very easy for us to collect and manage and provide the capability back to the customer for simple dashboards of just sort of monitoring what's going on the line today or last week or last shift. But the coolest thing about QUP Navi and having all this data is that we can then give you extremely capable root cause analysis tools to show these results of the same component side by side by side through all these processes. So if you ever do encounter an issue, we make it really easy for you to go back in time and figure out where the problem occurred, so that, we all have resource issues today, right? It's hard to find good people. We're all really busy. So it's capabilities like these allow you to improve your quality and use your valuable and limited engineering resources far more productively and far more efficiently, faster.
So I guess that you can take the data from each of the machines and kind of superimpose it on the top, so that you can then see, okay, this was okay here, it was okay here, but something had happened there. So perhaps then there was some kind of issue in the reflow process or something like that. So you can start to pinpoint those root causes that way, yes?
Exactly, right. It's very powerful to be able to follow that and find those correlations, so that you can go back and, identify where those defects occur and then figure out how to fix them, or at the very least, go in and quickly adjust your programs to identify that that would be fast, so that it doesn't make its way all the way down the line across a large product mix. Now QUP Auto is sort of the evolutionary next step of that. That's us looking outside of our world, so to speak. That's us incorporating data from other points in that line. Probably most specifically would be the pick and place, so that as we're doing those quality analysis features and capabilities within our software, and we're trying to do that root cause analysis, we can look for new trends and new levels of commonality at the pick and place machine itself. So if we see that defect at AOI, we can see if it was placed by, a common feeder, a common nozzle, a common head, so that we can then, as engineers, go back and maybe choose a different nozzle, or maybe just replace the nozzle, or maintain that feeder, do some sort of maintenance on that head. So those are the type of capabilities you need to get to that ultimate goal of, zero defect manufacturing. It's chasing those final 1 or 2%, those elusive gaps in your quality. Yeah, that is very challenging, and you need capabilities like this that are easy to use to do that.
So it's very interesting if you're taking the other information from like pick and place, as you said, because that puts you in a unique position whereby you are absolutely in control of all of the sources of variation in that line. So for example, if you were to send circuit board A down the line and then you do a thorough X-ray inspection and everything's fine, you then send a second board down and absolutely nothing in the process changed.
So
then
right.
Do you need to inspect that? Or maybe there is a hot spot, maybe that you would want to inspect a little bit, or maybe a feeder had been changed on the pick and place, and so the associated components, there could be some variation. So you can start to really prioritize the points of expected variation, and that would help you reduce the cycle time of your machine. Is that something that you've been considering?
Yeah, absolutely. I mean, we're chasing any solutions right now that sort of are driving towards our goal, or our 5-0 philosophy, if you will, of chasing waste, right? Waste in all its many forms, right? Whether that be PCB design constraints and not being able to inspect, whether that's zero downtime, zero operator programming, false calls, escapes, and at the end, zero defects. Any waste in resources, waste in time, waste in material handling, waste in transportation, waste in cost of repairs and things like that. So wherever we can use the AOI as the sensor that it is, because if you're just using your AOI to catch defects, okay, we get that, right? It's sort of managing the quality before it goes out the door. But if that's all you're doing, you're really wasting a lot of the capabilities, because it is a sensor giving feedback in your process, giving you the information to not only inspect your quality, but inspection in itself is waste, right? I wish, you didn't need inspection. Actually, I don't, I'd be out of a job, but inspection in itself is waste. If you have a tightly controlled process that is never going to change, then you don't need inspection. But the reality is, that's not the real world. Inspection is a necessity to maintain that quality.
I kind of see that the whole premise of buying an AOI or AXI or whatever machine is changed, because in the early days, you did buy it to filter your defects, to find the defects and put them right. But nowadays, you've got so much data there, you're in control of the process. You're actually not buying the machine to find defects anymore. You're actually determining the data with which to prevent defects from happening in the first place. because you're understanding the patterns of what is happening. And using Six Sigma, for example, I'm sure you can plot your data points going through and finding out, okay, this is going into a direction that could in the future trigger a defect if I do nothing. But if instead I inform my pick and place machine, as you said earlier, the nozzle may need to be changed or something may need to happen, you've eliminated all of the defects. So the purchase proposition, instead of buying a machine which some people could say is a waste because it's only there because you're making defects, actually it's now an added value part of the line because it is the thing that's preventing the defects.
That's
yeah,
true.
you see
I mean,
a pretty big shift.
Yeah, all these years back, who coined the term predictive testing, and predictive testing, of course, the holy grail of being able to predict something before it happens. So I think this is essentially where we're going with these systems. Anyway, Brad,
it sounds like you're in control enough.
So I want to thank you for giving us a tour through the Omron showroom and demo center. I mean, you've got so many products and so many items there. We could probably spend all day there. But,
I would love to do that.
Well, we'd love to do that too. But at least we've seen the highlights and we've seen some of the key new products that you've introduced to the market. And it's nice to see actually somebody showing us new products and not just iterations of ones that have been in the market a while. So thanks again, and thank you very much for joining us and showing us the Omron demo center.
Yeah, thank you. I really appreciate the invitation. This was fun.